Hello. Welcome to this talk. So yeah, we're sharing the talk, Monica and I. Haven't ever met before today, so it won't be a joined-up talk, but hopefully we'll cover two of the key features in Java 9. So I'm going to tell you a little bit about Java 9 modules. So just to introduce myself, so I'm Stephen Colebourne. I'm best known for date and time. So I wrote the JDK library. I also wrote the java.time library that's in Java 8. Java Champion been following things as they've gone on in Java for many years. So modules, it's this funny feature. It was meant to be in Java 7, then it was meant to be in Java 8, and now it's in Java 9. And as of 2 days ago, as of yesterday, the Java 9 schedule slipped for the second time in order to fit modules in. So this gives you some indication that it is a complicated feature, that it is going to affect the kind of code, the way you run code on the JVM, and they have to balance the question of keeping it compatible, so you can just take your existing code and run that, but still provide a way to move forwards in a new modular world. So it is effectively still incomplete. So I wrote these slides about 2 weeks ago, 3 weeks ago, and 4 days ago, a whole new proposal came out that changed quite a lot of what was on these slides, so I had to go back and revisit them. So yeah, it is all changing. It's classified under 6 different JEPs and a JSR. Now, there have been various different JSRs over time that have referred to modules. Some have come, some have gone over time as the scope of modules has changed. JEPs, for those who don't know it, that's the Open JDK's kind of low-level process for managing big tasks, whereas the JSR is the formal thing that goes through the Java community process that has to be rubber-stamped by 32 other bodies other than Oracle. So looking at the class path, that's what we've been using up until now. Classes are loaded on demand, so when you need a class, it will go and look at the class path, find the class, and load it up. And that class path, it specifies where do you find the bytecode. So you're specifying what jar files do you find the bytecode in. You can also specify a directory. You can actually specify zip files as well. There's also something called the boot class path. So that loads the actual JDK classes themselves. Something you may have seen, rt.jar. You can actually override the boot class path, so if you want to replace java.lang.object or replace java.lang.string, you can actually do that. Don't do that, but you can. And there's something called the extension class path, which nobody uses. Not very useful, really. So with those class paths, you then have the user class path, and that's where your code is loaded up. And so by default, it's the current directory, but you normally specify it, or your tool specifies it. And they can be anything you like. So how do these classes actually get loaded? Well, that's what the class loaders are for. So each class is loaded by one class loader. And a class loader is typically delegating to its parent. So you say, where is my person class? Is it in this class loader? If I don't find it there, I'll look in the parent one. Otherwise, I'll look in the parent one. So where's the string.class? Well, it's not in mine. I keep on looking up until I find the boot class path loader. So there's a class loader for each of those 3 class paths we talked about: boot, extension, and application. So yeah, my foo.class is in the application class path, string.class is in the boot class path. So these questions have long plagued the class path. What happens if a class is not on the class path? So when you start your system, it needs to find the first class. But what if later on down the line, you go into some new part of the system and it needs to load a class, and that's not on the class path? You don't find out until much later, until you actually try and use that part of the system, and you get a class not found error. What if a class appears twice on the class path? Not always well defined as to what one it's going to load, and obviously that can cause a mess. Does the order matter? Maybe. Do you know what that order is? Can you control that order? Best not to try. So generally, you don't want the same class loaded by 2 different class loaders, because they'll actually be effectively 2 different classes, and that's a real mess. So the module system is aiming to change the class path, to get rid of the class path is kind of its goal, it won't succeed in getting rid of the class path entirely, at least in the short term, but maybe over long term it will. So what they want is reliable configuration, so that when you start your system up, you know you've got all the classes you need. So in theory, if you're using the module system, you shouldn't get class not found error. Because when the system starts, it knows that it has all the classes you're going to need to run your code. That seems like a good thing. It also is intending to provide strong encapsulation. So this refers to a better way of hiding internal code. Now, if you have ever written a big system, you've probably had a package that was called com.mycompany.internal or .impl, where you were using that package name to indicate that nobody else should be calling that code. The goal of a module system is to make it so that nobody else can call that code, to actually lock that code away so it can't be called. So that's what's referred to as strong encapsulation. Now, all of that works on a per package basis. So you can only restrict and encapsulate that code on a per package basis. And ultimately, the thing is that this will provide a better JDK. Because if the JDK authors can lock away their internal classes, that makes it safer and more secure. And if you know that you have all the classes available when you start the system, you can perform certain optimizations that you can only do when you can see the entirety of the system. So whole program optimizations should provide better performance over time. It also means you can only depend on those parts of the JDK that you actually care about. So if you don't care about Corba, don't depend on that bit of the JDK that provides Corba. That seems like a good thing, particularly if you want to reduce the size of your footprint for either a mobile phone or for any other kind of smaller download. But of course, this changes the JDK. So there is no more rt.jar. There is no more single jar file that contains all the classes of the JDK. Instead, you're going to have a modular JDK. So there will be a file representing the java.base module, another file representing the Java SQL module, another one representing Java Desktop, and so on. So 30, 40, 50, I haven't actually counted how many modules there are in the Java, but yeah, the JDK will have more than one file now to represent. There's no more boot Classpath, and there's something called module path that's going to replace Classpath. Plus there's a new file called module-info.java, matching the package info.java that you've probably used before. You probably can't read that, that's fine, you're not really meant to read that, but that is the module diagram of the JDK. So right at the bottom is java.base, and looking very closely, next up from java.base we've got Java scripting, Java logging, Java instrumentation, a bit further up, SQL, RMI, a bit further up from that, management, and right at the very top you have java.se. So if you depend on java.se, you're basically depending on everything that the previous JDK used to provide. But by default, you'll only depend on java.base, which is a minimum subset. So you may need to express dependencies on parts of the JDK which you use. So what is a module? I've danced around that question up till this point. It's a named set of code. Now, I don't think actually, conceptually, it's that radical from what we've done before. A jar file we can treat as being a module in all fundamental conceptions. So basically, this module, it needs to specify what other modules it depends on, and it needs to say which packages it's making available for other modules to use. So those are the two key things it needs to do. As a module, what do I depend on, and what packages am I exporting to the rest of the world? So that module info.java file, that's where you declare this stuff. And because it's a .java file, it gets compiled to a .class file. And when the system is loading stuff, it basically says, if the jar file contains module info.class, then it is a module. And if module info.class is not there, then it is not a module. Fairly simple. This is what a module info file would look like. So here we've got a module we give it a name. Remember, it's a name set of code, com.opengamma. We say what other modules we depend on. In this case, I'm depending on com.google.guava and org.joda.beans. And from my module, I'm exporting two packages for other people to use. I'm exporting com.opengamma and com.opengamma.model. So that's a fairly typical, relatively minimal module definition. Nothing terribly radical in there, but it does allow a lot more to go forward from there. What that gives us in terms of a diagram is our com.opengamma module depending on the Guava module and the JDBeans module, and anybody who uses com.opengamma is getting those two packages we export. JDBeans might also depend on a module of its own. In this case, we're declaring the module JDBeans to depend on JDConvert and to export the package org.joda.beans. Great. That gives us this module diagram. So com.opengamma depending on Guava and beans depending on convert. So given these two packages, org.joda.beans and org.joda.beans.internal, we can completely hide that internal package. So in the module info file, you simply specify you're exporting JDBeans, and you don't specify that you're exporting org.joda.beans internal, or you just don't mention it. By not mentioning it, it is completely hidden. And when you're using the module system, no code from outside that module can use that internal package. So this has some interesting effects. So because only exported packages are visible to other modules, all those other packages are private to that module. So public no longer means public. Key takeaway, really. So although you write a class and it has the public modifier on it, if you're using modules, that does not mean that it can be used elsewhere. In order to use that class, it needs to be public and in an exported package and where it has been required by the other module. So module A has to require module B. Module B has to export the package outwards, and the class has to be public. And only if those three things are true will you be able to use that class. That's quite a lot more to think about. In this combination, they refer to as accessibility. Now this can cause some problems. So JDBeans, it depends on JDConvert, we saw that earlier. But it also happens that some of the JDConvert types are used as input types in JDBeans and as return types in JDBeans. So this means that effectively you can't use JDBeans without also being able to use the public classes from JDConvert. So this is referred to, they've changed the name of this, it was requires public, and now it's called requires transitive. So you can basically say, when you declare JDBeans, that not only do I depend on JDConvert, but I depend on JDConvert and I want you to make any exported types that JDConvert has transitively available as well. So here's how you might represent that on the diagram. So now, what the diagram shows is that the JDBeans module is adding itself an extra dependency to JDConvert. So anything that uses JDBeans will also get JDConvert available as a set of public classes. But what about reflection? And this is what's caused the big ruckus of the last couple of months on the module system, and has probably been at the root of delaying it another 4 months, because everybody said, you've kind of ignored reflection and not really got it right. So basically, when you're using the module system, we've just seen how those 3 steps that you need in order to access the public classes. But reflection can no longer access the private classes of that module. It's really strong encapsulation. So previously you might have used something like setAccessible to get at the private fields, private methods package scope methods, protected methods, setAccessible will no longer perform that function. Now, while you may have never written setAccessible, I can guarantee the framework libraries that you use do. If you use Hibernate and it's setting the private fields of something, if you use almost any serialization library, it'll be setting the private fields of something. If you use anything that refers to beans and is doing manipulation of beans and properties, it'll be accessing private stuff. So that's quite a big deal. There's no access whatsoever by reflection to non-exported packages, and there's no access to non-public things. However, and this is part of what's the big debate going on at the moment, what they intend to do is add effectively a separate mechanism where you as the module writer can allow reflection to carry on working. So at the moment this is called export to private. I've suggested that this should be called exposes. There's lots of debates around exactly the semantics. But the idea here basically is to say, on what I've got up on the board, I'm exporting the Joda Beans package, so the public types in that the rest of the world can see, but I'm exporting privately the internal package. And by using export to private, what I'm saying is that any reflection code can see any class in that package, and it can use setAccessible to get at all the private and package scope stuff. So reflection can carry on working. Which is good. I mean, I suspect that if you took an existing one of your applications that uses any kind of framework, you're probably going to need to write quite a bit of export to private in order to get those frameworks to carry on working. They're toying with the idea of something called a weak module that will basically do export everything for reflection and just export everything immediately for you. I'm not sure they quite got the semantics right, but we will see. So the module path itself, remember I said there's a module path now, as well as the class path. So on Java 9 you can come along and you can carry on using Classpath and you can make no changes and all your stuff will carry on working. But if you choose to opt into the module path, then what does the module path contain? It contains a set of modules. You basically say one of the modules is the root module, and from that module it will then work out what all the other modules are that are needed in order to start the system. So this is its reliable configuration. So it's going to ensure that it can find all the modules, it's going to ensure that there is no module found twice, and that the same package is not in two modules. Now I can guarantee the last one of those constraints is going to cause problems as people migrate to modules, because I bet in your jar files today you've probably managed to get the same package to appear in two of your jar files. That's not that uncommon in code as it migrates over time, but that's not going to be acceptable for the module system. So in essence what the module path does, what the system interpreting it is, it says you say my top module is com.opengamma, it reads the module info.class and it says well then this module depends on these two other modules, can I find those? And then recursively carry on down until it's got the entire graph set up. So with the entire graph set up, hooray, you've got a system which should hopefully start and run without errors. So what they've done with the class path is they've mapped it to something called the unnamed module. The idea is basically that the unnamed module can do all the things you'd expect the class path to do. It can access any other modules you do supply, it can access non-exported packages, it can do all the reflection stuff we've talked about. So most existing code should just run fine in the unnamed module. But if you have a named module, i.e. if you've opted into using modules, it can't access the stuff in the unnamed module. So a named module can't access the class path. So we're moving forwards and not allowing you to slip back. Services is the other thing that there's support for. So there's things like SQL drivers, XML parsers, lots of stuff. So this is the Java service loader class. You may not have come across it, but it is a long-standing part of the JDK that allows you to specify a mechanism for services. So what you can say in your module info is you can say that I'm providing the service com.foo.xml parser using the class myXML parser. And then the one that's using the service says, I use XML parser. So this allows the modules to declare specific dependencies on these services, and that's separate from the other stuff to do with exporting. In case of any misconceptions, so the module path has nothing to do with local Maven caches, has nothing to do with Maven, has nothing to do with version numbers. There are no version numbers in anything I've shown you. You're still going to have some other tool that is choosing between versions and doing version selection. So when you set up your module path, you have to specify a particular set of jar files, and that's not really that different to what you have on the Classpath today. When you run something using Maven, it's going to choose a set of jar files and put them on the Classpath. It's just put them on the module path in the future. And the module is not the same as a ClassLoader. So although there is always one ClassLoader associated with the module, any given ClassLoader may actually supply code for more than one module. Now this is different to OSGI, and I believe JBoss modules as well, where they map things specifically, so one module equals one ClassLoader. So that's different as well. So in this sense, Java SE9 is quite radical. If you opt into this module path, then you'll have to get all your dependencies to be set up as modules, and then you'll have to look at your code, make sure there's no shared packages, make sure the reflection works, look into strong encapsulation, make sure you've got the packages exported that you want to. Yeah, it's quite a big deal. Anyway, I hope that helps your understanding of modules.
Hello again. For those who saw me yesterday, welcome back. And for those who don't know me, I'm Monica Beckwith. Before I introduce myself, I just wanted everybody to get a glimpse of what JEPs are targeted for JDK 9. Okay, so this is the page that you could go to. You could go to openjdkjava.net projects JDK 9. You would see the schedule over there, and then the status. And if you look at this area here, JEPs targeted 2 JDK 9 so far, and this is the list. So JDK 9 is a big project. And I'll be honest, out of this list, I probably have either worked or looked at or tried to understand about 15 or 20. So I am no way even close to understanding the entire effort that goes into JDK 9. And I was working for Oracle, so that's where we are. So yesterday I spoke about G1, GC, I spoke about humongous objects. So we did cover some of these things that are included in this JEP. But as a performance person, I really try to see, although I know, we don't really know about performance till it gets released, but when I see something about improving, or for example in this case, improve contended locking, so that really caught my attention, and I thought maybe for this presentation we'll do, let's see if it's improved, right? That's what they want to show. But what was interesting to me is the amount of benchmark testing, especially stress testing, that they have listed here, and the project is already complete and delivered. So I really don't know if really for everything they have made sure that it's improved. But it's a good thing to know that they have some non-goals and some goals, and we're just going to try some simple benchmark, and I'll show you, we'll walk through the performance analysis, and I'll show you a glimpse of my life, how I do analysis. So let's play and start. Okay, so that's what I'm going to talk about today. I'm Monica Beckwith. I am an independent consultant. My company's name is Colebourne LLC. People who were there yesterday already know that I worked with Oracle, and prior to that Sun, and then prior to that AMD. And so basically I started from hardware performance engineer to compiler, static compiler, to Java, JIT, JVM heuristics, and finally kind of graduated to GC, and I was the G1 GC lead at Oracle. And then now I'm doing consultancy with, I solve managed runtime performance issues, so more higher level, but since I know the basics, so kind of really helps trying to solve issues. Okay. Um, so, so we have synchronized method, right? So now it'll automatically perform a locking action, as whenever it's invoked, right? Now, what if the method is an instant method, then the monitor will be an object monitor. But if you have the static method, then it will be a class manager, right? So just this basic knowledge is what is important in case you want to benchmark what I'm going to talk about, the contended locking stuff, okay? So let's understand the difference between uncontended and contended locks. It's the same synchronized method, but in the uncontended case, a single thread is executing that synchronized method. There's no contention, so that's why it's called uncontended. We have had so many optimizations in Hotspot and other JVMs for this uncontended locking, and so this new JEB brings about improvements to contended locks. So what does contention mean? A thread T is already locking that synchronized method, and a different thread U wants to enter that method. So now there's a contention. And that is what the optimization is doing. The optimization wants to improve contended locking performance, okay? Now, there's also a set of things that we need to know. I may not be able to touch it today, but we should talk about wait sets, okay? So in addition to having the monitor for the object, it also had some wait sets, okay? It's basically a set of threads based on how much contention you have and what you want those threads to do. So at creation, it's just an empty set of threads. And then and the way it can be manipulated is that you can say object wait, so that means it will wait. If it's contended, it will wait. If it's notify, then you have to notify and you pick a thread at random. And then notify all is basically all those that were waiting will get the notification. So this is something you can always read about, and I have two links, very good links, the JVM, the language specification link, and you can read more about that there. But I wanted to just highlight this here, and although I'm not going to be touching that, it's very important to keep that in mind. So here is the tool that I use for performance analysis. And I've been working with this tool since the beginning of time for my career. Basically, I use the same tool for static compiler analysis. Thank you so much. Thank you. And then when I moved on to Java Performance, I used the same tool. So I've been working on this for more than a decade now. What we need to know, and since over the years, this tool has been optimized so much that you don't even need to specify if your target is a JVM, okay? But just something to keep in mind, and these are the things, simple things that everybody can work with. And I will show you a quick demo as well. JON, so basically since this is a static compiler and a dynamic compiler profiling tool, in the past we used to have to specify JON, but we don't need to. There's also the default clock profiling rate of 100 samples per second, but you can change that. There's a low, high, or you can just specify the number. If you want heap tracing, you have HR. If you want to just record it, so usually I would go about, even if my experiment is running for an hour or so, I would go for about 4-minute window over the space that I want to profile. It's very important. And then I also do hardware counter profiling to look at cache misses and other things, okay? Right now, we're not doing any of those. So we're just going to concentrate on the JEP, okay? So in the summary of the JEP, they said improve the performance of contended Java object monitors, okay? So we create a quick benchmark that has contention in it. We make sure that it's contended. And then we try to see what targets have they listed in their JEP. So these are the targets listed in the JEP. Again, we don't have enough time to look at all the field reordering and cache line alignment because that's a big session in itself and very effective session too. So let's just compare locking in Java, contended locking in Java 9 to Java 8. Like I said, I'll show you how it looks, but I have just captured snippets in this presentation. Not going to talk about the first one yet, or not in this session at least. So we'll look at speed up platform event on Park. So when I profiled both my application and there's a way to compare time, and there's a way to compare inclusive time, so time in the method inclusive of all the calls from that method, or exclusive time, which means that the time that a particular method took individually. So I look at that, and this is the same benchmark running on JDK 9 versus JDK 8, and I do see performance improvement, okay? So it's 0.3 versus 0.08. Moving on to the next one. And it may look that it's so simple in class. But the thing I did here is like I worked on these different benchmarks that I've listed for more than 3 weeks. And not everything is so pretty. You know, some of them don't really have an improvement. I looked at some semaphores, fair, but you know, maybe it's not expected to do that. So I don't know, and that's why I've restricted my my experiments now, after learning the hard way, to these improvements that they have targeted. And it seems like just these targets that they have mentioned are actually improved. So maybe the entire benchmark doesn't improve in performance because of other changes that may have gone into. But these targets, that's why I changed the presentation around so many times, and I'm so thankful that you were accommodating because I didn't have any presentation ready till last night and this morning. So because I just didn't know how to send the message. You know, when you say improve and it's already delivered, what did they improve? You know, so I wanted to just highlight these things, and I'll show you how you can see these things or using that tool. So fast Java monitor enter operations. So in the tool, there were two different things. So there's one call to the other. So if you look at just the inclusive time itself is better. But I wanted to see the object monitor enter times exclusively, and even exclusive time is much better. So see, this is 8, it's taking more time. 9, very, very little time. Okay, and then the exit operation is the same thing. There's an epilogue for exit. Again, I'll show you this how it looks with this demo, and again, improved times again. So that's great. Everything looks great so far for the small micro benchmark that I wrote. But you know, and as a healthy exercise, maybe you guys want to write wait, notify, and notify all, and test the last one. So I'm going to leave you with a demo. So if you take home exercises, go write a small benchmark and figure out how notify gets better. And before I leave this, I want to show the JEP link as well as the specification link, and that's where you can learn more about notify all, wait, synchronized methods, and all those things that you need to know about locking and synchronization. Okay, so quickly going to the demo. Okay. I guess not so quickly. Yes. Okay. Is this working? Just 1 second. Mirror displays, okay? It was, but it's not showing the display. Oh, there it is now. Okay, good. You got it. I just didn't apply enough force. Yes, that's right. Okay. Okay. So we'll start from the how. So this is the tool. So once you do just collect, and then you run, you prepend that before your application, it creates an experiment. And then when you open the analyzer tool, this is what it looks like. Okay. So you go to open experiment, and you go to the directory where it creates an experiment. You could have easily named it something else. By default, it just goes test 1, 2, 3, 4. It keeps on adding it. So if you have more than 4 tests, then you probably need to just have a different name. But the good thing is, so for example, test 4 is what I had compared over there. You can see it'll tell you exactly the metric, and also it'll tell you in the overview, it'll tell you more about your experiment and everything else. So even if you forget what you did, see right here, it'll tell you what command line option I use and everything else. So it's good like that. So there are different modes. There's a user mode. If you look at the user mode, you'll see JVM system as a big blob right there. And there's no Java call stack recorded. So user mode is just for users, so whatever user libraries were used or whatever. It is not very useful for me, but it's good to understand. As a developer, you just need to see what you had overall picture. In expert mode, you will see everything. Everything is dumped on you. It really looks a little difficult to understand, and you don't know what. So you see the first one, that's the Contended Locks run that my benchmark, and then all of that is internal to the JVM system. What is easier for me is this, the machine mode, and I'll tell you why. Oops. There you go. So if I start by simple things, this directly goes into my code, right? But I don't care for it right now. What I care for right now is this, the caller and callees, because I'm trying to see, I was trying to test. So basically, first I ended up looking at the code and trying to figure out and compare. That was taking a long time. So for me, just to compare those 5 points, where if unparked was faster or not, I go down the call stack on the right-hand side. Okay, so we'll go down here. So total attributed time was 24 seconds. We'll go down here, and then we go complete monitor, locking, whatever, go down there, and object monitor, enter. And that's exactly what I wanted to see. So then, right, if you look at the right-hand side, you can tell that out of those 22 seconds, 11 seconds were taken by object monitor, enter, I. Okay, and that was the metric when I compared it. That's what I showed you. Now going back again. Anyway, so if we go back again, you can also look at other metrics. What's also good about this tool, and I want to make sure I have enough time. Yes. What's also good about this tool is this compare experiment. So this is the one that I had shown the metrics over here. So I'll compare it with test 2, which I know is my JDK 8 run. So test 4 is right here. Test 2 is the JDK 8 right here. Okay. So, and then the way the metrics are now different. So you have the baseline, which was my JDK 9 run, and then the experiment 1 is my JDK 8 run. And that's what I had shown the snippets when I showed the snippets earlier. And you can clearly see already, if I do by sort by exclusive, right there, you can already see the difference. So And then, so that's what I was trying to say, is that there's so much information, and I just wanted to specify the information based on the achievements that the JEP had listed. So this was the OS Platform Park event, Unpark event. And then now, maybe I want to go to expert mode and try to figure out the disassembly and look at the disassembly code if you want to learn more about it. So it's a very useful tool and kind of helped me figure out how not to go into the weeds and kind of kept me very into understanding the contended locking JEP. I think I'm done. If there are any questions or anything, I would love to take them now. I could go over more of the experiment, the profiler, if you want to, and we can look at more hardware profiling, how to do hardware profiling and stuff like that, or anything else. If nothing, then I can go sit down. Okay. Well, thank you very much for being here.